Welcome to the lecture series. In this lecture series, we are going to discuss about the memory organization in a microcontroller. So memory, it is a basic thing to store and retain the information which we process. So microcontrollers generally incorporate several types of memories, each serving a specific purpose. Program memory, that is flash or ROM. So we know program memory, that is flash, it is usually used for storing the code. Whereas RAM, it is a data memory usually used for storing the data and values. Program memory, it stores the firmware or the program instructions and it is non-volatile. So it can retain the data without the power. Typically implemented in a flash memory in modern microcontrollers, for example 32 KB to 1 MB in size. And next one is read-only memory or reprogrammer memory. As we know, flash allows the rewriting options. For example, store the compiled code of microcontroller to execute. And next one is data memory. Volatile memory used for temporary data storing during the program execution, holds variables, stack and runtime data. Limited in size, for example 1 KB to 256 KB depending upon the microcontroller which we have designed. And next one is subdivided into general purpose register and special purpose register. For temporary data and calculations, we use the general purpose registers, and for the hardware peripherals control like timers, input output ports controlling, we usually use the special register. And coming to the next type of memory, that is EEPROM. EE stands for electrically erasable program read-only memory. As we know, since it is a read-only memory, it is a non-volatile memory used for storing the small amounts of data, configuring settings and calibrating the data, and slower to write than RAM but retains the data without any power. And typically the size is small, that is 256 bytes to 4 KB. And next one is cache memory. It is an optional memory used in a microcontroller and found in the high performance controllers. This is small fast memory used to temporarily store frequently accessed data or instructions, and not common in the lower end microcontrollers. And coming to the architecture, as we know, we have three types of memories and one is optional. We are going to discuss about the types of architecture. First one is non-human architecture. It is a single memory space for both the program instructions and data. Simpler in design, but potential bottlenecks due to the shared bus. Used in some microcontrollers like certain 8051 based models. And second one is hardware architecture. It has separate memory spaces for both the program and the data, allows simultaneous access of instructions and data, and we can find it in the modern microcontrollers like PIC, AVR, ARM, Cortex M, etc. And coming to the organization part, first we have to focus on the program memory layout, and this is divided into fixed size blocks or pages. Example 5 and 12 bytes or 4 KB contains the bootloader section, application code, interrupt vector table. For bootloader section for initializing the microcontroller and loading firmware. Application code, it is mainly used for main program instructions, and interrupt vector table, it stores the address to interrupt service routine, that is the ISR's work. Address sequentially, that is starting from 0 to 0 for F or for the 64 KB memory. And next one is going for the data memory layout, as we have stack, heap, registers for storing the data memories, and stack we know for the function calls and the temporary data, and heap it is optional and it is a dynamic memory allocation, and registers we have general purpose registers and special function registers. And EEPROM layout organized as a separate addressable space, accessed via specific instructions or registers to read or write the operations. So we have program layout, data memory layout, and EEPROM layout, and each layout is designed for a specific functions and specific tasks depending upon the microcontroller being chosen. And next one is memory access and addressing. So we know what are the types of memory available and what are the types of architecture available, and next we have discussed about the organization layouts. Now we are going into the accessing and addressing. So we have addressing modes, that is microcontrollers use the various addressing modes to access memory. Address width determines the maximum memory size. and memory mapped input output, whereas peripherals are often mapped to a specific address in the data memory, allows software to control hardware by reading or writing to these addresses. And next one is banking or paging. This term is used in the microcontroller with a limited access space, divides the memory into pages or blanks with a register selected for the active bank, reduces addressable memory at once but allows larger total memory. In next lecture, we will discuss about the types of memories and also the addressing modes and types of interrupts available in microcontroller. Thank you.